do it. All right, first thing, I got two parallelograms in this diagram, two parallelograms. I should have did this before class, but if you have your own, feel free here. You may want to start highlighting some of these parallelograms I give you. So take a colored pencil or two, pass it around. If you have your own highlighters or colored pencils, let's get those out. And let's start highlighting the ones they tell us are parallelograms. So Wx is TV. All right, while you guys are waiting, let's get this going here because we got 4 to do today. We need to prove Wx congruent to Zy. Wx, locate them on your diagram right now. Wx right here, Zy up here. I don't see any triangles I'm going to try to prove congruent and say CP/CTC. So that's out of here. So we need to start getting in the habit of using some properties right off the bat. All right. What are Wx and Zy? They are sides of the parallelogram. All right, or the two parallelograms. Yeah. Oh, we're gonna have a little participation here. All right, I'm ready here, stud. So give me a pair that are congruent that I could use. Give me a pair of sides up there that are congruent that I could use. Okay, so here I got first one up right off the bat. VT is congruent to Wx. We're all in agreement. Reason, this is what I had you guys write down a few times yesterday. Parallelogram implies what property was just applied? Opposite. You got to have that word opposite. Can't have sides or congruent. Opposite sides congruent. Nice. So I have these two sides congruent. I need Wx and Zy though. I have Wx involved. Any way I can involve Zy now. Keep it rolling. Vincent, let's go. Because of the same reason, right? They're opposite sides. Everyone see that. So I'm just going to put it in statement 2 that YZ congruent to VT. Same reason. All right, keep building because this is why I think it's the toughest. You're going to use units 2 through, what are we on now, 6 in all these proofs. Because you're done with the properties right now. You're actually going to go way, way, way back to unit 2 when I used to have the pink and yellow pieces of paper up there to use one of these now. Yes, Maggie, finish it. Substitution. Everyone see that Wx and Yz both equal to Vt, so they have to be equal to each other, and that's going to be step 3, not 4. So Wx congruent to Yz, substitution. Not too bad right off the beginning. Not too bad. I didn't want to obviously hit you up with one of the tougher ones I could find. So everyone good there? Using a property. Anything you want to ask? One down. They will get tougher. Nothing? Going. All right, here we go now. Boom. I'll give you a second. Mark what you need to. Write in what you need to. I'm given that ABCD is a parallelogram. And I'm given a pair of sides congruent. Okay, you guys ready now? All right, we're proving triangles congruent. Hey, nothing's changing. How many methods were there? Proving triangles congruent. How many methods? Still at 5. That's not changing. It's going to be one of those 5 here. All right, but I did not start you off with any sides or angles. So can you use a parallelogram property or anything else to get a pair of sides or angles? Vincent, start us off here. DC and AB. Okay, so you're going this way first. I like it. DC congruent to AB. What's our reason here? Good. Parallelogram implies opposite sides congruent. All right, doesn't give us a side, but it could lead to a side, right? It could lead to a side, or you could go somewhere else in this proof. Go ahead. Anywhere else, Maggie, let's roll.
We could do DF minus DC equals CF, and then equals EB minus AB.
Everyone see the subtraction we're going to do. We're going to subtract the given sides from the ones that Vincent just gave us to give us EA and CF. Everyone see the subtraction going on? Yes, no? Okay. So we have, I can't read anything here now, DF minus DC is equal to EB minus AB. Subtraction. Nothing's changing here. What comes after subtraction? Substitution to say those sides are equal. And those sides we're talking about are EA congruent to CF. And that gives us a pair of sides. Nice. Got a pair of sides down. Okay, look for more sides or angles possibly. Look for more. Hi, Sinead, what's up? Yeah, DA, that's why I left that big gap in my proof there, because I was hoping somebody told me that DA is congruent to CB. Is that CB? Yep. No, C. What's this letter here? That's CB? That's CB? Okay. So DA congruent to CB. Same reason, that's why I'm going to add it, stick it in step 2. And that gives you another side. All right, so you got one choice here. You got 2 choices. You either show me the other pair of sides, so I could say side, 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 or you show me the angle in between to do side, angle, side. Those are your only choices here, guys. Only choices. You either get these sides congruent right here, or you get these angles congruent. So for side, side, side. Or side, angle, side. Okay, there you go. Oh, I got some hands here. Hello, Orion. Oh, do you?
So we could prove angle ABC and CBA congruent, and then say DF and DC and AB parallel, and then do ABC congruent to DAE and BCD, and then BCF congruent to CBA using alternate interior angles, and then just prove the 2 angles congruent with substitution.
You could. Multiple steps. Yes. I see. You're saying these 2 are congruent because they're alternate interior, which is correct. These 2 are congruent because they're alternate interior, right? And then, wait a second. Nope, sorry. I'm kidding. These 2, right? These 2, right? Alternate interior angles. These 2 are congruent, so you could do at least 2 substitutions to say those are. That's one way, yes? There's another way. Can I do it a little shorter, though? Yeah, just a slight short. Oh, boy. Yeah, what do you got there, Pete?
You can prove that angle DAC or DAB is congruent to DCB because opposite angles are congruent, and then you can do subtraction because it says they're lines, and get that angle EA
So you're saying, ready, everybody, those two angles are congruent. Everyone see where she's going there. Those two angles. And then I don't know if I'll go subtraction here. What do you know about these angles? Linear pairs, right? Linear pairs. We had a theorem up there that said what? Supplements of congruent angles are congruent. Everyone see where we're going there now. Okay. Paige, if you go the subtraction route, you still have to tell me these equal to 180 though. You need to tell me they're congruent, okay? Because they add up to 180. Or straight angles are congruent. That's what you need to tell me. You can't go right to subtraction now, okay? All right, so first thing, everyone, we need to say that those angles are congruent. Hopefully now you're believing me that, yeah, this is a little bit tougher, requires a little more work than usual. So what do we got? Angle DAB, calm down back there. Congruent to angle, if I go DAB, we got to go, let's see, BCD. Doesn't matter what we go. Okay, ready for it? Parallelogram implies, what property do we just apply there? Opposite angles congruent. All right. Now, I know this has been a while. Can I just say those angles, the other angles are congruent because supplements of congruent angles are congruent? Anybody remember what you must tell me before you use that theorem? What pairs are supplementary? All right. What pairs are supplementary? So angle. You guys can keep trucking instead of looking at the diagram. Why don't I just look at my own notes? Angle DAB and angle DAE are supplementary. And the same thing for the other pair, which is BCD and angle BCF. Anybody remember the reason? Linear pairs are supplementary. And now you can say those two angles inside the triangle are congruent. So angle DAE congruent to BCF. Supplements of congruent angles are congruent. Whew. 8-stepper. And then that gives me an angle, right? And then the triangles finally are congruent. Yes, Vincent.
You also said that DA and CB are parallel, and DAB and BC are congruent.
Wait, hold on. Which angles?
Lines DA and CB.
Yep, are parallel. So what angles?
DAE and BCF, because they're all points too.
Yeah, they're using two different transversals though. Like DAE, that's using transversal EB, and then BCF, that's using transversal DF. So you got to be on the same transversal. Any other issues there? Hey, not the easiest. We're all right though. Questions? 2 more? Okay, proving another pair of triangles congruent. How easy will this one be? Here we go. Oh, the givens are already written in. Look at you guys. All right, so parallelogram ABCD. Any properties apply to that beast right there? I got some perpendicular lines. Nice. What can I put on my diagram then? I can put some right angles up here. Yep. BE. Oh, nice. Right in the triangle, too. AF. Nice. Nice. Okay, you guys ready? Well, should we just put the right angles in there? Gives us a pair of angles, right? So angle F and angle BEC are right angles. Perpendicular lines form right angles. And then say congruent, we got a pair of angles at least. Okay, sides, angles, anything here? Sides, angles, any more? Let's dig deep. Hi, Dewey.
So you do line segment DA congruent to DC?
DA and DC?
Oh no, DA and BC.
Yes, you can. Yep, because that will give us a side. Nice job. Why is that true? Somebody else take over. Why is that true, that statement? Parallelogram implies, make sure you got parallelogram in there, implies opposite sides congruent. And I'd figured those were the first two you guys would get because the third pair is a little bit tougher to come by. A little tougher to come by. See if you can search for something else here I could use because you got a pair of angles and a pair of sides. You got it. You can do something else here. It's tough. It's tough to see. Haven't talked about it in 3 units. Hi, Meg. What do we got here?
Could we do the segment DA? Is that a transversal? So could we make angle FAD and no, wait, that's not possible. Never mind.
Okay. You tried. Tough to come by here. Hi, Paige.
I have a question before.
Sure.
Do you have to say that the lines are parallel before you? Okay, so then do DA and CB are parallel.
That is a true fact. I'm listening.
And then after you do that, you can say parallel lines imply that corresponding angles are congruent.
Whoa, out of nowhere. Corresponding? What are your corresponding angles there? Explain, young one. I'm still listening.
Oh. FDA and ECB.
Okay, everyone take a look. These two angles right here are indeed corresponding. Anybody remember corresponding? I'm gonna make this a disaster, but just to try to show you the best I can, these lines are parallel, cut by this transversal right here. And remember corresponding angles, you take this 4-pack, move them down, and see how those match up to each other. All right, but like Paige said before, you need to tell me the lines are parallel before you tell me the angles are congruent. So DA parallel to CB. Parallelogram implies opposite sides parallel. And then, yes, you can tell me those angles now. So angle FDA congruent to angle C. What would be my reason here? Something we haven't used in a while, but there we go. Parallel lines imply Corresponding angles congruent. Nice. And that gives me my pair of angles I need. Looks like the triangles are congruent. You guys just need to figure out for me, is that side in between or not? Because it's going to be either angle, angle, side, or angle, side, angle. We just have to determine if that side's in between or not. So triangle FDA congruent to triangle ECB. Anybody? Side in the middle or not? Here you go. Is that side in the middle? Absolutely not. So what method to prove these two triangles? Angle, angle, side. Wow, huh? Corresponding angles. Yep. Questions from any of you guys there? Anything at all? Nice job, Paige, there, noticing those. All right. Hate to do this to you, but we are in what course? Yep. And here's where I would end my geometry AB course right here. We'd ended it with this proof, but since we are at the honors level, I will continue to this proof right here. Something a little more challenging for you. Luckily, we're still proving triangles congruent. All right. I think you guys should be able to rip off two pairs of angles or sides right from the get-go and have no issues. Vincent, let's go. CB and DA, got a pair of sides for me, thank you. DA congruent to CB. Parallelogram implies opposite sides congruent. And hopefully you can rip off one more thing. Parallelogram property. Rip it off here. Caitlin, go. Great job. A and C congruent. Because parallelogram implies what property did Caitlin just apply there? Opposite angles congruent. That's why it's important to know those properties. All right, so right away we got 2 out of 3. And here's why this is an honors level one, because this third, whoa. All right, let's just get rolling here. What given haven't we touched? Because you know I provide the givens for you to use them. Roman, which one did I not touch? This whole midpoint thing, I have not touched. Have not touched the midpoint. Ready? E is the midpoint of AB. So what two segments are equal? AE and EB, right? F is the midpoint of DC. So what segments are equal? DF and FC. But I need FC and AE equal. All 4 aren't equal. These 2 are and these 2. But does everyone see I need those 2 congruent? Yeah. Yep. That's our problem. I can't say, hey, I can't go AE congruent to FC definition of a midpoint. I'm done. Can't do that. Can't do that. Nothing's coming up yet, huh? Oh boy, there it is. Don't say anything yet. You're taking the midpoint of how many segments? How many segments are you taking the midpoint of? Anytime we cut 2 or more segments in half in the same proof, what do we use, Maggie? Oh, digging deep. Halves of equal quantities. Everyone remember that when I had 2 midpoints in a problem. Yeah. All right, let's not just get nuts here. There's a couple things you need to tell me first before you can actually write down halves of equal quantities. You first have to tell me what you're... Oh, Jasmine, hi. Go ahead, contribute. Yes, what you're taking half of are equal, right? Halves of, what's the theorem? Halves of? Halves of? Okay, I don't have the equal quantities yet. You're about to take half of. So again, Jasmine, what do I need to write down? DC and AB are congruent. Yep. If you guys left any room on statement 2, pop that in there. Or if you want to rewrite it again, go ahead. That's your call. What you're taking half of needs to be equal. All right, we're still not there yet. What's the theorem? Halves of. So you better take half of these two and tell me what they're equal to. Okay, so here we go. Half a DC. Half a DC. You got 2 choices. I'm only concerned with one of them, though. FC. And half of AB, the other equal quantity. I'm only concerned with one of them. Which one do you taking off? A, E. All right, this is not because halves of equal quantities, though. How do I know that half a DC is equal to FC? Definition of midpoint. And then finally, yes, you're taking half. What do you know about DC and AB? DC and AB, what do we write down? Halves of equal quantities. Now you can say finally that the sides FC is or congruent to, equal to, I'm not concerned, AE, halves of equal quantities. Oh, welcome back. And then that gives you your side. And then what method are we talking about? I don't know that method. Side angle side, yep. Never taught that one. And then, yep, you guys can just get trucking here. Please, again, please, please look on Aspen for the answers. Come tomorrow with all your questions. Get it going. Please leave the color. If you borrowed any colored pencils, please just leave them on the desk. All right, don't get them on the floor.